All right, so for those of you watching the video at home, I forgot to record this video, so I had already gotten started on the notes. So I'll kind of go through and explain what I have already explained to the class. So what we're doing today is we are graphing higher degree polynomials. We've only graphed so far lines, which are linear functions. They have 1 degree, right? We've graphed quadratics. A quadratic polynomial makes a parabola. That's the U shape that opens up or down. And the highest degree in a quadratic function is 2. That's a quadratic. Well, we've never graphed anything with 3 degrees or 4 degrees or 5 degrees. And that's what I'm going to teach you how to do over the next couple of classes. Okay? So, and different methods, because different polynomials you have to factor in different ways. You just have to look at the polynomial and determine, okay, well, what am I going to try to do to solve for the x's? You got to know what the x's are, because that's where the graph crosses the x-axis, and that's one of the most important parts of the graph. Okay? So, what I'm teaching you today is when you see 4 terms in a polynomial, no matter how many degrees it is, when you see 4 terms, you're going to say, okay, well, when I have 4 terms, it's possible that I can factor by grouping. All right? Can't do that with 3 terms. We can do it with a quadratic, but you have to create 4 terms. But if you're just given 4 terms, always think, let me see if I can factor by grouping. You may not be able to. I'll show you once we get the problem going how you know if you can or if you can't, okay? So the first thing you're going to do when you have 4 terms, factor by grouping, is you're going to group the first 2 terms together, and you're going to group the second 2 terms together. So to group them, I just draw a line under them. So I'm going to group my first 2 terms and my second 2 terms. And again, what we're trying to do is factor this polynomial so that we can solve it. When we solve it, we find where the graph crosses the x-axis. When you're doing this method, if there's a GCF at the very beginning of the problem, don't factor it out, okay? Wait till you group your first 2 terms together and your second 2 terms together, and then you're going to factor out the greatest common factor from each group. Factor out the GCF from each group. Even if your greatest common factor is only 1, usually when your greatest common factor is only 1, we don't factor that out. Oops, sorry. But when you're doing factor by grouping, if that's all you have for the greatest common factor, then you do factor it out, okay? So in my first group, look at your coefficients first. The first term has a coefficient of 1. The second term has a coefficient of 3. What would the greatest common factor be of 1 and 3? Just 1, right? But variables can also be part of the greatest common factor. So your first term has 4 x's, because you look at your exponent. There's 4 of them. X times x times x times x. Your second term has 3 x's, because x's exponent is 3. So just looking at the first 2 terms, do they both at least have 1x? Do they both at least have 2 x's? Do they both at least have 3 x's? Do they both at least have 4 x's? No. So what's the greatest number they have in common? 3. So my GCF would be 1x cubed from my first group, or we just say x cubed, right? We don't need to say 1x cubed. So the greatest common factor of the first group is 1x cubed, or we just say x cubed. So we're going to factor that out. So to figure out what's left, to go inside the parentheses, you divide each term by the greatest common factor. Think about it like I had 4 x's in the first term, I took 3 out, what's left? Okay, that's what you're doing when you divide. So what is x to the 4th divided by x cubed? X, because I had 4 x's, I took out 3, I got 1 left. What's positive 3x cubed divided by positive x cubed? Positive 3. Because I had 3 x's, I took all 3 x's out. The coefficient's 3. 3 divided by 1 is just 3, right? Now listen, the second group, when you take out a greatest common factor, you have to also take out a sign to go with it, a positive or negative. How you figure it out is, whatever the sign is of the first term in the second group, that's what you're going to factor out. It doesn't matter if they're both negative or not. One could be positive, one could be negative, okay? They don't have to have the sign in common. Whatever the sign is of the first term in the second group, that's going to be the sign of your GCF. You have to take a sign out. Now, coefficients, I've got -1 and -3. So I'm going to factor out a -1 if that's all there was, but I could have variables, okay? Do they both at least have one x? Do they both at least have two x's? No. So what am I going to factor out for a greatest common factor? -x. So when you see what's left, don't just divide by x, you have to divide by -x. So first of all, we know a negative divided by negative is a positive, so that first term is going to be positive, right? And what's x squared divided by x? I had two x's, I took one out, how many's left? 1, so just x. For the second term, what's a negative divided by negative? Positive. What's 3x divided by x? 3. This is how you know, once you get to this part, you know if you can factor by grouping or not. Just because you have 4 terms does not mean you can factor by grouping. So how do you know if you can or not? Look what's inside parentheses. They both have an x plus 3, right? If what's inside parentheses is identical, then you can factor by grouping. If it's not identical, say you forgot to take out a -x and you took out a +x, so these signs were wrong, it's because you took out the wrong sign. So just double check that. But if what's in parentheses is not identical and you did not make any mistakes, then you can't factor by grouping, okay? But if this is exactly the same thing, then you can factor by grouping. Okay, well, what does that mean? So once you know that you can, make 2 sets of parentheses. The identical factor, take that out and put it in 1 set of parentheses. Because technically it's a greatest common factor of these 2 terms. I still only have 2 terms because it's products, okay? So basically you're taking out the GCF. What you had on the outside of your parentheses, the x cubed and the -x, group those together in the other set of parentheses. Now, what you have in parentheses may be able to be factored further. If you can factor further, do that, okay? X plus 3. This polynomial has 1 degree. It's linear. The only way to factor a linear polynomial is if it has a greatest common factor. If it doesn't, then it can't be factored any further. Does x plus 3 have a GCF other than 1? No. So x plus 3 can't be factored any further. Look at the second polynomial. It has 3 degrees. Okay, so 3 degrees, think sum of cubes, difference of cubes. Well, x cube's a perfect cube, but x is not a perfect cube, right? So it's not a difference of cubes. Notice it has a greatest common factor, doesn't it? We got to factor it out. Okay, so x plus 3, I'm done with that. I'm going to bring it down. I've got a GCF in that second group. And I know this seems like a lot on the first problem, but once you do a couple of them, it'd be no big deal. What is the greatest common factor of that second binomial? X. My first term has 3 x's, my second term has 1 x, so they only have 1 x in common, correct? So I'm going to factor out an x to see what's left. We'll divide each term by x. So what's x cubed divided by x? X squared. What's -x divided by +x? -1. Now listen very carefully. Technically, x squared minus 1 can be factored further because it's a difference of squares. It's a perfect square minus a perfect square. So if my whole goal was to factor completely, that's not factored completely. However, my goal is to solve for x. So if I set x squared minus 1 equal to 0, since I have the quadratic term and the constant, but I'm missing the linear term, then I can solve that without factoring it further. Okay, so I can go ahead and factor that, or I can just set it equal to 0. It can be solved. I can show you what I mean. I can do it both ways in a minute, but I know y'all like a shortcut, right? Do it the fastest way possible. So I'm just going to leave it like it is. So once we have factored completely, or we actually haven't factored completely, but we factored good enough to find the zeros. Remember, zeros, another word for it is solutions or roots or x-intercepts. All of those words mean the same thing. Set each factor equal to 0 and solve for x. As a reminder, remember at the top of our paper we wrote the degrees tell you how many zeros you had. And didn't we say this polynomial had 4 degrees? It's the highest number of degrees. So we should have 4 zeros when we're finished, okay? So my first factor is x plus 3. Set it equal to 0. Since x has 1 degree, I know I'm going to get 1 solution from that factor. My next factor was just x. Set it equal to 0. X also has 1 degree. That's going to give me 1 solution. My third factor was x squared minus 1. Set it equal to 0. Well, for that factor, x had 2 degrees. So I should get 2 solutions from that factor. You hear me? So 1 solution from x plus 3, 1 solution from x equals 0, 2 solutions from x squared minus 1 equals 0. So that should be 4 altogether, correct? Okay, so let's solve those. For x plus 3 equals 0, x is not isolated. What do I got to do? Subtract 3 from both sides. X equals -3. That's 1 solution. That's 1 x-intercept, 1 0, 1 root, whatever you want to call it. They all mean the same thing. The next factor, x equals 0. Can x equal 0? Yeah, a lot of kids think, oh, that doesn't work because it can't be 0. Yeah, your graph can cross the x-axis at 0. If that was a number like like 3 equals 0, well, 3 can't equal 0. 3 is a factor, but it wouldn't give you a solution. But if it's a variable set equal to 0, you can do that. Okay, for x squared minus 1 equals 0, what are we going to do? Add 1 to both sides. So x squared equals 1. Have we solved for x? No, we've solved for x squared. What would we do at this point? Square root. We're going to take the square root of x squared. And remember, when your root is even, you can take the positive and the negative root of the side that does not have a variable. That's how we're going to get 2 solutions. I don't know why those lights just came on. So what's the square root of x squared? X equals, what's the square root of 1? 1. It's positive 1 because 1 times 1 is 1, right? It's also -1 because -1 times -1 equals +1. See how we got 2 solutions from that? So -3 is 1 solution, 0 is another solution, so we've got 2. +1 is a third solution, -1 is a fourth solution. We had 4 degrees, so we should have 4 solutions. That's why it's super, super, super important to know that the number of degrees tells you how many solutions you had. Because if we know that and we think about it, a lot of times y'all are going to forget to take the positive and the negative root if it's squared. Well, if we forgot that, we would only have 3 solutions, right? We would say -3, 0, and 1. But if you're like, wait, it had 4 degrees, so I should have 4 solutions, that would let you know something's not right here. And hopefully that would help remind you that when you take the square root, you have to take the positive and the negative square root. Does that make sense? Okay. Now that we know where the graph is going to cross the x-axis, let's draw an x and a y-axis. And I know I need to go at least to -3 on the left side, at least. And on the right, I need to go at least to +1. And I'm not too worried about my y-intercepts, or how I label my y-axis. All right, so I have 4 x-intercepts. I'm going to plot points on the x-axis at those intercepts. So I know my graph's going to cross the x-axis at -3. I'm going to plot a point there. It's going to cross the x-axis at 0. So I'm going to plot a point when x is 0. My graph will cross the x-axis at +1 and at -1. Well, there's got to be more to the graph than that, right? Okay. Remember when I taught you end behavior? It's going to come in handy right now. If you were absent when I taught end behavior, I posted the video on Schoology. I posted the video of me teaching it, and I posted Algebra Nation's video teaching it. I think I posted Amy. Y'all know Amy from Algebra Nation. If you don't like either of our videos, you can go to Algebra Nation yourself, go through ClassLink, and you can find 2 other people teaching it, Darnell, and I don't remember who the other girl is that teaches it. That's 4 options that you have to learn in behavior, okay? But if you were here and you were paying attention, to find in behavior, you look at your polynomial when it's in standard form and look at the very first term. I would scoot my paper down, but it's all cattywampus up here with my document camera, and I've got it straight right now, so I'm not going to do that. But our problem was given to us in standard form, and the very first term was x to the 4th, right? So you look at your first term, you look at your exponent. Is it odd or even? Even. We know an even exponent, the end behavior is going to be in the same direction, either up, up, or down, down, okay? To determine if it's up, up, or down, down, you look at the sign of the coefficient. Well, my coefficient, there's technically a +1 there, correct? So it is positive. Your exponent, you look to see if it's odd or even. The coefficient, you look if it's positive or negative, okay? So this is a positive even. Would that be up, up, or down, down? Up, up. The left side's going to point up, the right side's going to point up. So the left side, go to the 0 furthest to the left, and you want to do an arrow pointing up. Don't make it straight up because it's probably not going to go straight up. The right side of your polynomial is going to point up, so go to the 0 that's furthest to the right, and you want to do an arrow pointing up. But you have to have other curves in there. It's not going to be like the left side and go straight across all the way to the right side, okay? So we got to take it back. The last time I taught you guys, which I know was 2 weeks ago, I told you how to determine if your graph is going to bounce at a 0 or an x-intercept or root, or if it's going to cross the x-axis at the x-intercept. Y'all remember? You remember learning it though? You have any idea that we talked about? Okay, so this is how you know. Bounce means, like say at -3. If it bounced at -3, as I'm going to the right, my graph would come to the -3, bounce back up. It wouldn't cross the x-axis. That's a bounce. If it doesn't bounce and it crosses the x-intercept, as I'm going to the right, it would cross over the x-axis at -3. How do you know? Do you remember when I taught you about multiplicity? Anybody? Yeah. Multiplicity is how many times does this solution occur, okay? How many times do we have a solution of -3? How many times did -3 happen? 1 time. So -3 has a multiplicity of 1. How many times did we get a solution of 0? Once. So 0 has a multiplicity of 1. How many times did we get a solution of +1? Just 1 time. So 1 has a multiplicity of 1. How many times did we get a solution of -1? Once. So it has a multiplicity of 1. All of my solutions had a multiplicity of 1, okay? So if your graph is going to bounce, then at that solution, it has a multiplicity that occurs an even number of times. So like say we had -3 occurred 2 times. That has a multiplicity of 2, 2 is even. If it has an even multiplicity, it bounces at that solution, okay? If it has an odd multiplicity, it doesn't bounce, it will cross the x-axis at that 0. So since all of these have an odd multiplicity, none of them are going to bounce. They're all going to cross the x-axis at that 0, okay? So going from left to right, we have to fill in the graph between the zeros. We know it's going to happen on the ends. Between the zeros, we're just sketching a graph, so it doesn't have to be perfect. But if it's going to be a bounce or go all the way through, we have to show that, okay? So at -3, it's not going to bounce, it's going to go through. And I don't really know how low it's going to go, but I know it's going to start turning up to pick up that next 0. At -1, I got to cross again, right? And it's not going to bounce at -1. If it was, it would turn immediately and start going back down, but it's not going to bounce. So I'm going to intersect the x-axis. I'm going to cross over to -1. I'm not really sure how high, but I got to come back down to get that next 0. It doesn't bounce at 0 because 0 did not occur an even number of times. So it's going to cross at 0 again, and it's going to go back down and curve to pick up the next 0. And then I know what happens on the ends. So on the ends, I don't have to, there's no more curving, okay? I don't know these minimum and maximum values. I don't really know what they are. It may have went way lower than I did, or I might have gone too low. I don't know. I'm just sketching what happens in between, okay? If we want to know exactly, we have to do some more math or use a graphing device. We're just sketching. So what we know for sure is what the ends are going to do, where they're going to point, up or down, and we know exactly where our x-intercepts are going to be. But what happens in the middle, we're just sketching. But we do know if it's going to bounce, it needs to look like a bounce. If it's going to go all the way through the x-axis, it needs to go all the way through. But how low or how high it goes, that's just a guess. That makes sense. We're just sketching that. And that's my graph. I promise they won't all take that long. Y'all know how I do. I over-explain on the first one, write everything down, and then I go faster after that. So we do need to write a little thing about how do we know if it bounces or whatever. So, and I'm kind of out of room. So I'm going to write down here. Remember, if a 0 has an odd multiplicity, and if you still are confused what I'm talking about with multiplicity, go back to the previous 2 lessons that I taught before I was absent for 2 weeks. Watch them. If you weren't here, if you're new to the class, go back and watch them because they're very important to what we're doing the next 3 days. Remember, if a 0 has an odd multiplicity, the graph will cross the x-axis at that 0. And if the graph has an even multiplicity, the graph will bounce at that 0. Anybody have questions about that? And we'll do several of these. So the first one, you're like, what? Okay, we got more. Am I still writing? All right, example 2. Let's see if I can get this. All right, we're going to graph x cubed minus 4x squared minus 3x plus 12. And something I forgot to point out. Do y'all remember when I taught you how to graph parabolas? That you could just look at the problem and tell what the y-intercept was? Do y'all remember? Any idea what the y-intercept would be on this problem? Whatever the constant is. What's the constant in this problem? 12. Remember, constant is the number that does not have a variable. Okay? I forgot to point it out on the last one. In the last example, what was my constant? Did any of those numbers not have a variable? No. So the constant would be at the end. If there's no number at the end without a variable, what is it? 0. Did my graph cross the y-axis at 0? Yeah, it did. Okay. So that's why I forgot to point it out, because I knew where it was going to cross. But on this one, we have a constant that's not 0. So that's another point that we're going to know. So I am going to be concerned about the y-axis on this one, because I want to make sure it crosses the y-axis at 0. Okay. So that means y-intercept. I just forgot to point that out on the last one. Okay, so do we see 4 terms here? Yeah, so 4 terms, we're going to try to factor by grouping. How many degrees are there? 3. 3 degrees tells us there's going to be how many zeros or roots or solutions? 3. 3 degrees means 3 zeros, also known as roots, solutions, x-intercepts. And my very first term is x cubed. It's in standard form, right? X cubed. Let's talk about end behavior. The exponent is odd or even? Odd. And is the coefficient positive or negative? Positive. So we know odd is it's opposite directions, either up, down, or down, up. If it's odd and positive, it's going to end on a positive note, which means it starts on a negative note. So what is that? Down, up, down. Down, up. Left side points down, right side points up. So we're going to need that when we go to graph, right? But we got to figure out what the x-intercepts are. So we're going to hopefully factor by grouping and then set each factor equal to 0 to find the x-intercepts, right? So group your first 2 terms together or group your second 2 terms together. What is the GCF of my first group? X squared. So I put that outside of the parentheses, and I divide each of only the first 2 terms by x squared to see what's left. What's x cubed divided by x squared? X. What's negative 4x squared divided by x squared? Negative 4. Remember, in your second group, you have to take the sign of the first term in the second group. So let's talk about the sign. What's going to be the sign of the GCF of the second group? Minus, because the first term in the second group is negative. They don't have to both be negative. It doesn't matter. Whatever the sign of the first term is. Do they both have x's in the second? No, so we know x is not going to be part of the GCF. Well, look at your coefficients, 3 and 12. Does 3 and 12 have a common factor? 3. 3 divides into negative 3x evenly, and 3 divides into 12 evenly, right? It can't be any number larger than the smallest number. So it's either going to be 1 or 3. 3 it is. So we divide each term of the second group by the GCF. What's negative 3x divided by negative 3? The negative divided by negative is positive. 3 divided by 3 is 1, and then x. So 1x or just x. What's positive 12 divided by negative 3? Negative 4. At this point, I'll know, yes, I can do factor by grouping. It will work for this problem. Or no, I can't. Can we? Yes. If what's inside parentheses is identical, yes, we can do factor by grouping. So you make 2 sets of parentheses. What was identical in one set? That's technically the greatest common factor of these two terms. You factor it out, put it in one set of parentheses. What's left on the outside, the x squared and the negative 3, group those terms together in the other set of parentheses. Do either of those two sets of parentheses have a GCF? No. X minus 4, I can set that equal to 0 and solve for x. X squared minus 3, because I'm missing the linear term. It's not like it's x squared plus x minus 3. When you're missing a linear term, you can set that equal to 0 and solve for x. Okay, so we're ready to do that. So x minus 4, set it equal to 0. X squared minus 3, set it equal to 0. How many solutions are we supposed to get for this problem? 3, because there's 3 degrees, right? How many are we going to get from x minus 4? 1, because x is to the first degree. How many are we going to get from x squared minus 3? 2, because x's highest degree is 2, right? All right. So one of my solutions is positive 4. The other one will have to do a little bit more work. First, we'll isolate the x squared by adding 3 to both sides. So negative 3 plus 3 is 0. Bring down your x squared. Bring down your equal sign. 0 plus 3 is 3. Is that my answer, 3? No. I've solved for x squared. I need to solve for x. What do? Square root of x squared, and the positive and negative square root of 3. Bless you. What's the square root of x squared? X equals. Now, the square root of 3, is 3 a perfect square? No. Generally, I would just leave it positive, negative square root of 3, like if we were doing the quadratic formula or completing the square or whatever. But since we're graphing this, do you know where the square root of 3 is on your calculator or on your graph? No, so let's put it in our calculator, okay? Now, I know that the square root of 3 is going to be, I think that's 1.7, right? And it is. Positive or negative 1.73. So positive 1.7 and negative 1.7. We have 2 solutions. Don't round it up to 2. I would at least go to the nearest tenths place, okay? If it was 2, that means 2 is the square root of 4. So at least go to the tenths place. Do we have 3 solutions? Do any of them occur more than once? No. So the multiplicity for each one of my solutions is 1, right? So none of them will bounce. When we graph, we're not going to have any bouncing. They all only occur once. So we are ready for our x-axis. And remember, our y-axis, the y-intercept is 12. So on the y-axis, I'm going to go by 2s. And I still didn't. I'm going to be up there. That's okay. And on the x-axis, I need to go at least a positive 4 and at least a negative 1.7. So my y-intercept is 12. I got that not from factoring, but because it's the constant, right? That's my y-intercept. My x-intercepts are positive 4, positive 1.7. I'm going to have to approximate that. and negative 1.7. If you don't learn your end behavior, then you're going to have to do a whole lot more math. It's just easier to memorize what the end behavior is. We've already said, we said it from the beginning, the left side will point down, the right side will point up. So go to your 0 furthest to the left and do an arrow down. Go to the 0 furthest to the right and do an arrow up, down and up. And then you have to draw curves in between each consecutive set of zeros. So we need to draw a curve between negative 1.7 and positive 1.7. Well, our y-intercept is between those 2 points, correct? So we know we got to go up and get that point. And really, see how I drew my, this would not zoom out like that. It would probably go more like this. But I didn't know that. And if I was using a pencil, I could just, because it's going to be a smooth curve. It's not going to make that sharp turn like that. There's no bouncing. From between 1.7 and 4, I know there's going to be another curve between those. And that looks pretty smooth. And there we go. So 3 degrees means 3 solutions. We had 3 solutions. Leading coefficient was positive and odd. Our end behavior should be down and up. Our y-intercept was 12. We made sure of that. Also, which we'll talk about this later, but that you can't have, the number of curves has to be at least 1 less than the number of degrees. So 3 degrees, you can't have any more than 2 curves. We had 2. That's like when you change directions, okay? So we had 1 change of directions here, and we had 1 change of directions here. That's 2. Coolio? Anybody have a question about that one? All right, example 3. So probably we won't have homework today. Probably give you a class assignment on Thursday. And a lot of you still have some work to do from when the sub was here if you want full credit. So that will be your assignment. No excuses next class. You left it at home, it's late, okay? Today I will take that excuse. Thursday I will not. Do we have 4 terms here? Yeah, and I know that has the greatest common factor, but if you're going to do factor by grouping, don't factor that out at the beginning, okay? What is your y-intercept? 0, because my constant, there's not 1, because they wouldn't write plus 0 on the end. Remember, constant is the term that doesn't have a variable. Since all of these have variables, your constant would be 0. So we know the graph's going to cross the y-axis at 0, correct? Okay. So we're going to factor by grouping. I'm going to group my first 2 terms together and my second 2 terms together. What is the GCF of the first group? X what? X cubed, x to the 3rd power, x cubed. So I will divide both of the first 2 terms by x cubed and see what's left. What's x to the 4th divided by x cubed? X. What's positive x cubed divided by x cubed? 1 plus 1. Not 0. A number divided by itself is not 0. It's 1. So x cubed divided by x cubed, you get a positive 1. What's going to be the sign of my second GCF? Negative. It's whatever the sign of the first term is. What's the greatest common factor of the second group? Negative what? Negative 3x. Does everybody see that? So I'll divide each of the second 2 terms by negative 3x. So my first term, first of all, what's a negative divided by negative? Positive. What's 3 divided by 3? 1. What's x squared divided by x? X. So positive 1x, we just write that as x. Next term, what's a negative divided by negative? Positive. What's 3 divided by 3? What's x divided by x? So positive 1 times 1 is just positive 1. Is this problem going to work with factor by grouping? Yes, because what's inside the parentheses is the same. So once you know it's going to work, make 2 sets of parentheses. What's going to go in one set? X plus 1, whatever's in the parentheses. Just take one of them out. What's going to go in the other set? What's on the outside? X cubed minus 3x. We group that together. X plus 1, that's a linear polynomial. The only way, because it has 1 degree, the only way to factor a linear polynomial is if it has a greatest common factor. Does it? No. Look at my second group. Does it have a greatest common factor? Then we need to factor it further. Okay? So x plus 1 is good. We're good with that. What's the GCF of the second group? X. My first term has 3 x's. My second term has 1 x. So don't they both at least have 1 x in common? And then coefficients 1 and 3 is 1, so we'll just take out x. So if I divide each of those by x, what's x cubed divided by x? X squared. What's negative 3x divided by x? Negative 3. Now this is quadratic, but because you're missing the linear term, if I go to solve this, I can solve it. I don't need to factor any further, and I can't factor x squared minus 3 any further. That's not a difference of squares because 3 is not a perfect square. Okay? So I have completely factored. How many zeros am I supposed to get for this one? We didn't write that at the beginning. How many degrees do I have? 4 degrees. So how many solutions or zeros or x-intercepts? So 4, let's call it zeros. And then what should my end behavior be? Yeah, my first term is x to the 4th. Your exponent is an even number, and your coefficient is positive. So even, we know that's up, up, or down, down. So even positive is what? Up, up. And we know that the y-intercept is 0, right? So let's find the x-intercepts by setting each factor equal to 0. X plus 1 equals 0. X is a factor. Set each factor equal to 0. And x squared minus 3 is a factor. How many solutions are we going to get from x squared minus 3? 2 solutions, right? Because it's squared. All right, x plus 1 equals 0. What's the solution? Negative 1. X equals 0. X is already isolated. There's nothing to solve. 0 is a solution. So far, I have 2 solutions. X squared minus 3. We'll get 2 solutions because x is squared. So x squared equals 3. Now what? Square root. And make sure to take the positive and negative square root of the side that does not have a variable. So what's the square root of x squared? X equals positive, negative. What's the square root of 3? We just did it. 1.7. That's 2 solutions, right? Positive 1.7, negative 1.7. How many solutions do we have? 4. Negative 1, 0, positive 1.7, negative 1.7. We should have 4 solutions because we had 4 degrees. Is my graph going to bounce at any of the zeros? Do any of them occur 2 times, 4 times, 6 times, 8 times? No. So at each of the zeros, it's going to cross the x-axis, right? And we know the y-intercept 0, so I don't have to worry about how high or low I'm going. So I can squeeze my graph in over here on the side. I know on the x-axis, my smallest number is negative 1.7. My largest number is positive 1.7. And I don't really need to worry about the y-axis because my y-intercept is 0, right, Logan? So x-intercepts, I've got one at negative 1. I've got one at 0. I've got one at positive 1.7 and at negative 1.7. 4 x-intercepts. The end behavior is up and up. Far left, I'm going to do an arrow coming up. Far right, I'm going to do an arrow coming up. Between negative 1.7 and negative 1, I'm going to have a curve. And it doesn't bounce here, so we know it's going to cross to some point and then come back up and pick up the next consecutive 0. Between negative 1 and 0, I'm going to have another curve, and it's crossing the x-axis, so I know it goes above it, and then it's going to come back down to get the next 0. I have another curve between 0 and 1.7. There's no bouncing here, so I'm going to cross and curve to come back up to get the next 0. I could have a maximum of 3 curves because it's 1 less than the number of degrees. I had 1, 2, 3 curves, no more, right? Maximum of 3. Doesn't mean you're going to have 3. Maximum of 3. Julio? I've got 2 more to squeeze in. 8:15. We can do it. You may have a question? I'll be posting this video before I leave, so if you do have a question, you're going to have your assignment next class over this. Might need to watch it again. If you don't know what I'm talking about in behavioral multiplicity, go back and watch the previous videos that I posted. Module 5. All right, example 4, we have x cubed minus x squared minus x plus 1. Do I have 4 terms? Yeah, so I'm going to hopefully do factor by grouping, right? How many zeros do I have? 3. And I know that because I have 3 degrees, right? 3 degrees means I'm going to have 3 zeros. Zeros are the same thing as solutions, roots, x-intercepts. Look at your leading term, it's in standard form, leading term to determine end behavior. The exponent is an odd number, and the coefficient is a positive number. I don't care if the coefficient is odd or even, I care if it's positive or negative. So odd, we know is opposite directions, either down, up, or up, down. If it's positive and odd, what do we have? Huh? Down, up. It's going to end on a positive note, so the right side's going to point up. And hey, what is the y-intercept going to be? Positive 1, because my constant is positive 1. So I know a lot about the graph, but I really need to know the x-intercepts. Okay, I don't want to just make those up. So that's why we do the factor by grouping. So group my first 2 terms together, group my second 2 terms together. What's the GCF of the first group? X squared. They both have at least 1x. They both have at least 2 x's. They don't both have 3. So I can take a maximum of 2 x's, right? Divide each of those terms by x squared to see what's left. What is x cubed divided by x squared? X. What's that? My next term was a negative divided by a positive. Negative. What's x squared divided by x squared? 1. Whenever you divide a term by itself, you get 1. What's going to be the sign of my next group? Negative. It's whatever the sign of that first term is. What's the GCF? 1. Usually, like if we were doing quadratics and the GCF was 1, we would say it doesn't have a greatest common factor. But when you're using this method, you have to have 2 terms in each set of parentheses. So if all you got's a 1, positive 1 or negative 1, that's all you got. You take it out, okay? So I'll divide each of those terms by negative 1. What's negative x divided by negative 1? First of all, what's a negative divided by negative? Positive. Anything divided by 1 is itself. So what's x divided by 1? X. Next term, what's a positive 1 divided by a negative 1? Negative 1. Is this problem, are we able to do factor by grouping? Will it work? Yes, no, maybe? Yeah. What's inside parentheses is identical. That means a yes. We can use factor by grouping. So once you know you can, make 2 sets of parentheses. These are technically only 2 terms. The product is a term. X squared times x minus 1 is 1 term because it's a product. This is a product, 1 term. So these 2 terms have a common factor of x minus 1. That's why you only take it out 1 time. It's a GCF. What's going to go in the other set of parentheses? X squared minus 1. Technically, x squared minus 1, that's a difference of squares. I can factor that further. If my directions were to be factored completely, I would need to keep going. But I know when I have a quadratic term and a constant, if I'm solving it, I don't need to factor it further. I could, but I can solve it, and that's really what my goal is, what I'm trying to solve, okay? So once I have my factors, neither of them have a greatest common factor. We would want to factor that out. Set your factors equal to 0. and solve for x. For x minus 1 equals 0, I'll add 1 to both sides. X equals 1. There's one solution. How many should we have total? 3, because there's 3 degrees, right? How many am I going to get from x squared minus 1? 2. So I'm going to add 1 to both sides. X squared equals 1. Now what? Square root both sides. If I forget to take the positive and negative square root, I'm going to only end up with one solution here, right? I should have 2 because it's x squared. So you got to remember to take the positive and the negative square root. Square root of x squared is x equals positive, negative. What's the square root of 1? 1. Positive 1 and negative 1. So I have 3 solutions altogether, correct? How many times do we have a solution of 1? Twice. So wouldn't we say x equals 1 has a multiplicity of what? 2. When you have a multiplicity of an even number, what does that tell you about the graph at that 0? It's going to bounce, right? So x equals 1 has a multiplicity of 2. Since this is an even multiplicity, we know the graph will bounce at x equals 1. Now, is it going to graph at negative 1? No, because negative 1 only occurs once, right? So when you get to x equals 1, the graph's going to bounce. At negative 1, it will cross the x-axis just like they've all been doing. And don't forget our y-intercept is positive 1. So we know on the y-axis, it's going to cross at positive 1. So I'll at least want to go up that high. My smallest x value is negative 1. And my largest x value is positive 1. So my y-intercept was positive 1, my y-intercept. We know that. We didn't have to do any math. It's whatever your constant was. We said that at the beginning. One of my x-intercepts, negative 1, and positive 1 occurred 2 times. So I have 3 solutions. It's just that one of them is a repeat. It has a multiplicity of 2. The end behavior is down and up. Left side points down, so go to the 0 furthest to the left, point your arrow down. The right side points up, go to the 0. We only had 2 zeros, 3 technically, but 1 repeated, so it looks like 2 on the graph. So how many times is this going to curve? Just one time, because we only are going to have a curve that we know of between consecutive x-intercepts. We only have one set of consecutive, right? And we know that it's going to have a y-intercept of 1. So we'll just pick up that point. Oh, no, I lied. At positive 1, it's going to bounce. So between at negative 1, it crosses, right? It's negative 1. So we're going to cross at negative 1, pick up positive 1. Am I going to go down below negative 1 here? No, I'm bouncing. So once I get to 1, it's going to bounce right back up. It's not going to intersect. It bounces because there's a multiplicity of 2, which is an even multiplicity when x equals 1. So I would not cross there. Bounce. Whenever you have a number that is a solution 2 times, 4 times, 6 times, 8 times, 10 times, it will bounce at that solution. If I had a multiplicity of it occurred once, 3 times, 5 times, 7 times, an odd number of times, it just crosses at that solution. Y'all cool with that? All right, let's see if we can do example 5 super fast. This is my page 3. Got my pages mixed up. All right, example 5. I would have you do this one on your own, but my time is running short. X to the 4th minus 5x cubed plus 5x squared minus 25x. I'm going to go quick, okay? Do I have 4 terms? Yeah, so I'm hoping I can do factor by grouping. How many degrees do I have? 4 degrees, so how many solutions or roots or zeros am I going to have? 4. I'll call it zeros. And behavior, it's in standard form. My very first term is x to the 4th. So you have an even positive. So your end behavior is going to be what? Up and up. Group my first 2 terms together, group my second 2 terms together. What's the GCF of the first group? X cubed. Factor it out. X to the 4th divided by x cubed is x. Negative 5x cubed divided by x cubed is negative 5. What's going to be the sign of the second GCF? Put positive. What's the greatest common factor? 5x. So divide each of those terms by 5x. 5x squared divided by 5x is x. Negative 25x divided by positive 5x is negative 5. Can I factor this? Yeah, yes, because what's inside parentheses is the same. Make 2 sets of parentheses. That identical factor is technically the greatest common factor. We factor it out, put it in 1 set. That's why you only have it once, not twice. What's on the outside, x cubed and positive 5x, we group that together in the other set. Notice that second set of parentheses has a greatest common factor. We need to factor it out. What is the GCF of this group, x cubed plus 5x? X. So I need to factor it out. So I divide each of those terms by x. X cubed divided by x is x squared. Positive 5x divided by x is positive 5. Now, none of my factors have a greatest common factor. I can now, bless you, solve. I should be getting 4 solutions because I have 4 zeros. So for x minus 5, I'll set it equal to 0. X is a factor, set it equal to 0. X squared plus 5 is a factor, set it equal to 0. One of my solutions is positive 5. One of my solutions is 0. And then x squared plus 5, I should get 2 solutions here. X squared equals negative 5. Take the square root of both sides. What is the square root of negative 5? Did you put negative 5 square root in your calculator? Huh? Yes, because negative 5 square root, you get an error message. Why do you get an error message? Because you have a negative under the radical, right? Which means you get an imaginary solution. So positive negative I square root 5. Hold on, don't leave. Just give me a second so you understand this. So I have 4 solutions, 5, 0, positive I squared 5, and negative squared 5. I have 4 solutions. But with your imaginary solutions, you won't see those on your graph. So your graph is only going to intersect the x-axis at 0 and 5. These count as 2 solutions, but you're not going to see them on the graph, okay? So y'all can go. I'm going to finish this video. Y'all still in here? We're still doing this, okay? And I'll write that in a minute. So the only x-intercepts I'm going to have are at positive 5 and at 0. And we know the y-intercept was at 0. So at positive 5 and at 0. And I'll write about the imaginary solutions in a minute. Okay? So we have 4 solutions, but your x-intercepts only come from the real solutions. Any imaginary solutions? They're not x-intercepts. Our end behavior was up and up. So this looks like a quadratic because it had 4 degrees. It's possible that you could have 2 terms in between 0 and 5, both below the x-axis. You could do that. We wouldn't really know unless we did some more math or did graphing calculator. But please don't pack up yet. Write this down. 2 of our zeros are imaginary numbers. and you will not see them on the graph. Another thing, the maximum number of turning points, this part's important, we have not written it down yet. The maximum, I gotta spell it right, number of turning points of a polynomial is always one less than the degree of the function. We may not know exactly where they are, but at least we know the max. So real quick, I want to show you that this graph that we just drew with a y-intercept of 0 and 5, with the end behavior, since there's 4 degrees, we could have had, it could have gone, see how I have 3 turning points there? But they're both below the x-axis, so I still only have the same zeros. It could be like that, or like this. We don't know unless we do more math, okay? But we know we can't have any more than 3 turning points. Julio? All right, so we'll do an assignment over these notes next class. Remember, all sub work, do next class if you want full credit. And not graded for accuracy. If you turn it in after that, maximum 60%, and it will be graded for accuracy. If you're absent next class, turn it in on Schoology. And have a great day.